Awesome. Thanks, Brian. Yes, and welcome everyone. My name is Greg Woods. I'm a software engineer at Neo4j. And in this session, we're going to be covering the query API and more specifically, its type formatting. And Neo4j has had a long history with HTTP. So from version 1 in 2010, shortly after came the first way you can connect externally to Neo4j via the HTTP API, which allows you to execute Cypher via HTTP, as one might expect. And some time passed, and towards 2016, we switched focus to starting to develop our in-house drivers that use a binary protocol called Bolt. Our development switched focus towards these drivers at some expense of the existing HTTP API, and the API somewhat lagged behind functionality of the Bolt drivers. We have put some effort to bring this API up to standard, up to feature parity with the Bolt drivers. But given its age, it's been very difficult to keep all those features forwards. And now 5 years ago, almost to the day now, Aura was released. And this was accessible via the Bolt drivers, but unfortunately not the HTTP API. And this is where the query API comes in. So 2 or 3 months ago now, we released the query API into Aura. And of course, the main benefit of this now is that HTTP is available in Aura. So by this, it's across all tiers in Aura, so including free tier, and available now. So can be tried without any cost to yourselves. Now, why might you choose, or why might querying data via HTTP be more desirable or useful? So whilst we have support for many drivers, many different languages, official drivers from Go, .NET, JavaScript, Python, and our community drivers, we unfortunately can't support every single language out there and all the tooling that is available. But most programming languages, almost certainly all programming languages, have some sort of HTTP client, which means you can pick any language you'd like as long as it has a HTTP client, and you can now query your data using it. And this also goes for tooling. It's like HTTP is ubiquitous and has support for many different tooling. So you're not restricted by how to execute Cypher. Another environment we think this API could be used for is serverless ones. So whereas a driver might have a bit more machinery behind it and dependencies involved, with this query API, you can execute Cypher without any dependencies, which we think will make an ideal choice for serverless environments where things like creating extremely small deployment artifacts allows you to scale things quicker and without a connection pool restrictions. And finally, the one other use case that we think this will be useful for is restricted networks. So maybe you can't, for some reason or another, use Bolt in your network infrastructure. You have some security limitations or just limitations in your network setup. HTTP could be a great choice for you because, as I said, standard tooling and pretty much all middleware supports it in one way or the other. Why wouldn't you choose this API? Well, performance would be the main one. So the query API has been designed with ease of use as a key design goal. And as hopefully you'll see that in a minute, that's how it works. So this means when we've made a choice between between ease of use and performance, we've leaned towards ease of use. And therefore, if performance is important to you, we recommend that you use one of the official drivers. And of course, the query API is a low-level API allowing you to execute Cypher via HTTP, and that's all it does. And typically, you want to do some more further processing on your data. And therefore, we would recommend you use one of the tools that is available to you. So, got a great set of tools in different languages to help you carry on processing your data after execution, from object mapping in Java and JavaScript. And in the graph data science libraries, we've got a great Python client that allows you to do really cool stuff with that. If you're connecting data sources, we've got stuff like change data capture libraries. And if you already have some standardized stuff in your setup, like JDBC, we support for those too. So these are the choices that this is the choice you have to make. Yeah, and without further ado, let's have a look at the API. So the first thing you want to do is log into your Aura console and hopefully have an instance running. As I said, Query API is available across all tiers, including free tier, just so happens I'm using professional in this case. And what you want to do is come down to this connection URI and take this part of it, because the Neo4j plus S is a bulk protocol, and we want to use HTTP. So you just copy this part, and then now you choose the client that you want to use. As like I said, we use any tool we want. It's up to you. In this case, I'm going to use curl, which I hope most people are familiar with. And this is what the curl query looks like. -U for user and Neo4j. This is the credential that you get when you first start your Neo4j instance, when you hit the download button for your credentials. And the body of the request is just a simple JSON object with a statement property and a Cypher string as the query. For your headers, you can select content type headers, it's application JSON, and your accept header is also application JSON, but it's not strictly necessary because it defaults to application JSON. And then this is where your connection URI goes in here. And yeah, by the way, this is HTTPS, so it's a secure encrypted connection. You've got so from connection URI /db/ the name of the database you want to connect to /query /v2. And then we're piping the output to this tool called JQ, which will just print us out some nicely formatted JSON. So we execute this and we see the results coming back. We've got a JSON document with two properties, the data field and bookmarks. In data is where your results actually are. So the fields element contains the headers of the result rows, if you like, and the values contain an array of the records that form part of your result. And bookmarks here, which we won't go into in any detail, is something that can be used as input in the API to ensure causal consistency. So yeah, hopefully you can see this API is quite straightforward, pretty simple to use. Just to show a few more examples, and yeah, there's lots of other things you can do and configuration options you can choose. One we would recommend is the access mode header that allows you to tag your queries with information that helps routing them to appropriate cluster members. And this is exactly the same query as before, so we should just be able to hit this and get the same result. It's not particularly interesting, but of course you can also return all sorts of stuff that comes from a Cypher statement. So any Cypher, valid Cypher goes in here. In this case, we're creating a node. And if we hit the results here, we now see something a bit more complicated, but element ID, labels, properties, everything's there where you would expect it to be. And the final example for this is parameters. So you can also parameterize your queries and put those in as input, and that works pretty much the same way. So that's the plain type, or the pure application JSON type format. But this talk has something to do with types. So where does that come in? So hopefully, as you're aware, Neo4j has a large type system. So from primitive types to like Booleans and numbers to our graph types like nodes and relationships. Now the problem is coming to map those types onto JSON types. And as you can see, there's a much smaller set of types, and therefore we have to make a mapping or a many-to-one mapping onto these types. And in the process, we might lose some important information. And just to hammer this home, we've got here on the left 3 different Neo4j types, and their pure values all get mapped to string, and therefore you lose the fact that they have type information. And this is fine if you're just reading results and you're not particularly going to do any more processing with them, but typically you do, and therefore you want to have some way to preserve that type information. And so how we do this is by extending JSON with this type information, and to get this nice one-to-one mapping between Neo4j types and this extended JSON format. And this is how we do it, by embedding into or creating a object with a type field and a value field. So the type field contains the type of the value that's being encoded in the value field. And in this example here, we have a number type, and you can see in the value field we have a number. And of course, I won't go through all the different types that we have, but there's one for every single Neo4j types, including these composite ones. Okay, so let's have a look at this in action. And yeah, this is exactly the same query as we had before, except this time now our content type and our accept headers are containing this vnd.neo4j.query, specifies the type format that I've just mentioned. So if we execute this, we should now see our results come back in exactly the same format, but now in our values element, each of the results contains that type pairing. And this is great not just for getting type information out of Neo4j, but also putting in. So if we return back to our parameter example, we can also explicitly tell the query API that we want to insert an integer here as a type over any other particular value. So if we execute this, we'll see that the result that comes back is a integer type. And of course, then we can switch and swap out the type with any value that we would like. So now we've got the same value or the same input here, but it's going to be interpreted differently this time as a string instead of as a number. And there we go. And of course, the type system goes all the way to all the different Neo4j types. So if we can take this previous previous query that we had before with this node and use it with the new type format, when we execute it, we see we got this node type, and now in the value attribute, we have the similar sort of stuff, but the bits that need typing have those type fields, mainly that this property is beautiful, contains the type pairing. And yeah, and as you can see, writing a parser for this stuff now becomes much easier, because when we want to read the results, we can first read this type field, and then we know exactly what we will expect in this value property. And yes, so that's basically it for all the type stuff that I want to cover in this session. Just to give you a flavor of what's coming up next in the query API, we've just finished working on explicit transactions. So you've seen in this initial release, we have a single endpoint, which is commit and request in a single transaction. But you maybe want to start a transaction, get your results back, and then decide what you're going to do next by running even more statements within a transaction, or before deciding to commit or roll back. And that's coming very soon. The next thing we want to explore is how to work with larger data sets and streaming of results in and out, or pagination of bigger result sets. And finally, this is a shout out for feedback. What would you like to see in this API? It would be great if we can receive your feedback in Discord. And finally, if you want to give the query API a try, we can go to this docs page here. It's great docs by our wonderful docs team. If you find the type stuff that I've been talking about interesting, I've wrote a more descriptive blog post going into much more detail here. And again, if you've got any questions or feedback, please reach out to us on Discord, or indeed, I will be hanging around and being available to answer questions in the chat. And yeah, with that, thanks very much.